Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 14.2, Problem 9. This is Section 14.2, it's problem number 9. It says an open box is to be made by cutting a square notch out of each corner of a square piece of cardboard. Let X represent the length of a side of the square notch that is to be cut from the 18-inch by 18-inch square piece of cardboard. And this diagram here, the dotted lines represent folds, so you're going to cut out a notch of length X. So after you cut it, the remaining piece of cardboard will look something like this, and you fold up the sides and you get an open box. Now, depending on how big of a notch you cut, you could wind up with a very tall, narrow box like this, or you could wind up with a very low box with a large base like this. And there's some perfect combination between tall and narrow and low and wide, depending on the size of the notch that you cut out, that'll give you the most volume from that 18-inch by 18-inch square piece of cardboard. So if we find the right formula, what we can do is see what notch is going to work the best for us. So part A says, find the value of X that will produce a box with the most volume. So again, we've started with a square piece of cardboard, and we're going to cut out a notch, a square notch of size X, and fold up the sides. And we want to find the volume, and after we cut that notch, we're going to have a box, open box. It'll have a square base, and it'll look something like that. So now to find the volume, what you have is the length, the width, and the height. And what you have to remember from some previous class that had geometry is volume equals length times width times height. And you want that computation to come out to as big a value as you can. And what volume you get will be determined by how big of a notch you take. 1 inch, 2 inches, 3 inches, 4 inches. So with some trial and error and enough cardboard, you could figure it out. But that's tedious. With calculus, you can figure it out and get it right on the first try. So the base of the box will be this distance here. So it starts with 18 inches to go from end to end. But now you're taking out an X from the left side and the right side. So the length will be 18, not minus X, but minus 2X. Again, an X from the left and an X from the right. That's going to be the length. Now the width, it's going to be a square base, that's with a square piece, will also be 18 minus 2X. And because of the way it's snipped here, the height will be X. So we can express the volume in terms of one variable. So volume equals the length is 18 minus 2X times the width, which is also 18 minus 2X, times the height, which is X. So there I have a function for volume based only on one variable. So we have to take the derivative, set it equal to 0, solve for X. Now, since I'm going to take the derivative, like I'm going to want V prime, I could do it like this, but I'm going to need the product rule for a 3-part product. It would work, but I feel it's well within my best interest to just clear all those parentheses and not have any type of product rule. So the first thing that I want to do is FOIL out these parentheses. Let me just let the X on the end coast there for a minute. So 18 times 18 is 324. Probably want to make these parentheses a little further apart. And then 18 times negative 2X will be negative 36X. Then you have this negative 2X times a different 18. That'll be negative 36X again. And then negative 2x times negative 2x is positive 4x squared. Pay attention to the negative times negative is going to be positive. X times x, x squared. Don't forget you still have an x outside the parentheses. Before I bring that x into the parentheses, which I'll do in a minute, let me combine my 36x and 36x in the middle. So v equals parentheses 324 minus 36x and another minus 36x. Let me put those two together and make minus 72x. Again, they're both negative. Combine them, keep the x. And then I have a 4x squared on the end. And then x outside of the parentheses. Now I can multiply the x outside the parentheses into every piece inside the parentheses. So now v equals, so x times 324 is 324x. X times negative 72x will be negative 72x squared. And then x times 4x squared will be 4x cubed. So now it's written with no parentheses. One last thing I'll do that I don't have to do, I like to see the highest exponent written first. So let me just rearrange all of this. So v equals, so let me put the 4x cubed first. Then the minus 72x squared can stay in the middle. And then plus 324x I'll put on the end. Now that's more the way I like to see it. So there's my function in terms of one variable with a little bit of work. So far no calculus yet. This has all been algebra. Now the calculus. Now let me take the derivative of v, and I'm going to have v prime. I'll write it over here. So v prime equals this 4x cubed. The derivative of that is 12x to the second. And again, that's coming from the exponent of 3 coming down times the number in front of 4. 3 times 4 is 12. The exponent drops by 1 from a third power down to a second power. The next piece of my function for v is minus 72x squared. The derivative of that will be minus 144x to the first. And that came from the exponent of 2 coming down times the number in front of negative 72. 2 times negative 72 is minus 144. Reduce the exponent by 1. That second power drops down to a first power. And the 324x on the end becomes just 324. When you have something with just an x to the first, the derivative is just the number in front of the x, in this case 324. So now here's v prime. Next step, set it equal to 0. It's an easy step. So just take the answer from the line above, 12x squared minus 144x plus 324, and after it just write equals 0. Now solve for x. Because I have a second power, I have to solve by factoring. Second power, I expect 2 answers. So you have to notice that everything is something times 12 in this equation. So let me write a 12, make some parentheses, and now 12 times what is 12x squared? Well, just times x squared. Then 12 times what is 144x? That would be 12x. And pay attention to the sign. Minus 144, so minus 12x. And then 12 times something is 324. It is 12 times 27. So now what I have to factor has smaller numbers to deal with. This 12 can stay in front. So I'm going to make some parentheses, x, x. And I'm looking for 2 numbers that multiply to make 27 and add together to make a negative 12. So when you factor this. So for 27, you really have 2 choices. It's either 27 times 1, which no way will add up to make a 12, or 9 times 3, which will make a 12. So the 9 times 3, then you check the signs, both the same sign, both negative. Minus 9 minus 3. So 2 factors, 2 answers. The x minus 9 factor gives me an answer of x equals positive 9. Again, if I put in a 9 for x, it makes the equation true, 0 equals 0. And the other factor of x minus 3 gives me a solution of x equals positive 3. Again, where I have an x, if I put in a positive 3, it'll make the equation true. Now, two answers. Well, the x equals 9 is the minimum volume for the open box. Because if the box is 18 inches across and you snip out a 9 by 9 snip, there's nothing left, so you'll have a volume of 0. So the x equals 9 will produce the minimum volume. The x equals 3 will produce the maximum volume. So what is the value of x that will produce a box with the most volume? The value for x is 3. So the height of that box is 3. Now, part B says, what is the maximum volume that can be made this way? So, again, if I have my open box with a square base like this that I've been drawing, and the height is 3, and the base is 18 minus 2x, and x is 3. So I've snipped off 3 from each side from 18. So the first 3 you snip out of the 18, you're down to 15. Another 3 for the other side, you're down to 12. So the base is 12 by 12, and the height is 3. So the volume, which was length times width times height, winds up being the volume is the length is 12, times the width is 12, times the height is 3. So 12 times 12, I have 144 times 3. And if you multiply 144 times 3, it's 432. Now, you have to put the units. This was in inches, and we're volume, so the units are in cubic inches. So the most volume you can get out of an 18 by 18 square piece of cardboard by snipping out x notches like that is 432 cubic inches.